Let's get started. Again, welcome. We're going to go to our targeting software first. It's called Astro Planner, and let's go here and make that a little bit bigger so that you all can see that full screen. There we go. And let's do a sort on that targeting software by visibility and altitude. How about that? And now let's look up here at the top and see what we got. M56. All right, looks like we're connected to our scope, so let's try to slew there.
Pier West.
And I have an iPad set up here to view the actual telescope, but in the moments before we were getting ready, I was not able to get it connected yet. So I think I'll work on that in a minute. Does look like the telescope is functioning okay.
Slewing complete.
All right, getting a good look at the camera out there at the scope. Let's go to our planetarium software and let's cancel out of that for a second and just look, see if we can connect again. See what happens if we try to connect. No, that's not going to work for now. So we'll come back to that in a sec. See if we can get that working. Let's go over to our imaging software, which we're using SharpCap, and let's drop back to a full screen image. And wow, that's doing great there. Look how sharp those stars are. My goodness, this is what we've been working on over the past month, and look how pinpoint sharp each of those stars are. That's incredible. I'm going to go here to the broadcasting software and make sure you're seeing that. Wow. So what we're looking at, let's do a plate solve here and make sure we're on track. This is our first object, and typically there's a little bit of an adjustment to be made between 3 and 6 degrees on the first object. You notice we're running at 2 seconds, and the gain is 400, which is pretty high, but seems to be working. Let's see. Do you want to? So it's 9.6 degrees
Syncing to coordinates.
On our first
Slewing
object.
to coordinates.
So what it's doing now is it's comparing the sky that it's viewing
Slewing
through its
complete.
camera with the database it has. Let's go ahead and see if we can live stack this, but I tell you what, why don't we switch this to about 10 seconds and bring our gain down to something more manageable, something like 200, something like that maybe. Let's do a 10-second. That doesn't look bad. I think that'll work. And let's put in our target name here, which is M56. It's a globular cluster, M56. And we're ready to live stack here. So it typically takes, now the telescope we're using is a RASA. It's an 8-inch RASA, and it is sitting on top of Skywatcher EQ6R mount, and the camera is a ZWO ASI2600MC Plus. So it's a color camera and it is being cooled. We typically run it around 8 degrees. That seems to be plenty. Let's do a reset over here in the display histogram, and let's do a reset here on our image histogram, just to kind of start from scratch. And then let's do a reset on our colors and a color balance to match uh, our peaks in our histogram. Let's bring the blacks over to around the top of those peaks, and then bring our mids in a little bit. And you can see how that brings out a lot more of the stars. We don't need quite that, the whites to be all the way over there. I mean, it doesn't hurt probably to leave them there, but let's compress those a little bit so that and you can see right there in the middle. Now while that's capturing just a couple more live stacking frames, subframes, let's go over here to the live stream, and it does look like we have about 6 people viewing. And if you would like to say something on there and kind of tell where you're from, we'll try to be ready to dialogue with you there. But in the meantime, let's zoom in on this globular cluster a little bit. Let's come into about 33%. You can see it's right there in the middle, and this particular globular cluster is M56. Let's go over to uh, our planetarium software for a second, and let's listen to what our planetarium software audio tour sounds like for this object.
M56 is a hard-to-spot globular cluster in Lyra the Harp. So rich with stars is the foreground that M56 is often lost, and even experienced observers have trouble finding it. The little cluster lies about midway between the 2 stars that make the bottom of the Harp and the colorful double star Alberio in nearby Cygnus. M56 appears as a small round ball with tight little arms coming out of making strings of stars. It can be glimpsed in binoculars on a good night where it looks like the head of a small comet. This cluster would be better known if it were located in a less confusing field.
All right, let's go back and see what oh boy, that is a beautiful cluster, isn't it? It's let's zoom in a little bit more. Let's come into about 75%, or maybe even a full 100%, and center on that. And this greenish cast, I wonder if that's a normal. Let's pull in a little bit of a few of those, a little bit more of those colors. And I'm just curious on this cluster. It's apparently one of the fainter Messier objects, but notice how the stars in the middle, it's about 32,900 light years away, and it's about 85 light years across. The brightest stars are around 13th magnitude. I'm just curious how many stars you think would be in this cluster. I mean, they're all different colors there. It'd be hard to count them. I think it's a beautiful object. I know that some people are not uh, big fans of globular clusters, but boy, I am. I think they look like Christmas lights. Hey, Jeff, glad to have you here. You sure are up late in the middle of the night with us. Welcome. I'm just going to ask you, Jeff, are you hearing the audio okay? Because I wasn't able a while ago to monitor that audio. I'm going to try that one more time on my phone. Just see if, oh yeah. Now I'm monitoring. It's because, I'm pretty sure it's because the headset was also logged onto the phone. So I did take the headset off the phone and that let me hear the audio. So I think we're okay. So this is M56. I'm gonna snap a an image of this. I'll save exactly a scene. And then I also like to grab a kind of a close-up of these because that helps us in our targeting software to get a nice looking picture. That's So this is M56 as seen on 2021 0805. And then what we'll do is we'll dash back over to our targeting software and we'll just add a user image there so we get the preview of that. And this is M56. And so you see how that puts our image there. And then we'll also do a new observation of this. And we'll say something like, let's see, makes me makes me feel makes me why is there a makes me feel like Christmas. That's what this object reminded me of. We'll pull in the full image of this. Here and that's M56. Now we're ready for M57. Let's go back over here to SharpCap and stop the live stacking. Boy, that's a beautiful shot of it there, M56. And let's head to M57. This is the Ring Nebula.
Slewing to coordinates.
And like I say, I have an image of the telescope on an iPad here beside me. But in the moments I had before we started the live stream, I just could not. Well, there's Lance. Welcome, Lance. And Jeff, thanks for that reinforcement on the audio. Like I say, what I had done is my headset was logged into both devices, and so it was not letting me hear when I checked it. So I'm looking at the scope on an iPad on a kind of a surveillance. It's one of those WiseCam 3s, and I just regret that I
slewing complete.
Didn't get that all figured out as to how to reflect that into the actual live stream before the live stream started. But maybe we'll work on that in a second. So we are at M57. Let's go back over to SharpCap and put M57 in the target. Let's change our zoom back to auto, and let's do a just a little check on that with the plate solving. Lance, I remember recently you were kind enough to email, I think, and we exchanged a message or two. So it's good to have you on the live stream. If you get a chance, Lance, kind of tell us where you're watching from. And looks like Jeff,
syncing to coordinates.
A familiar.
Slewing
Looks like
to coordinates. Slewing complete.
0.35 degrees off. So that's not bad. This is the Ring Nebula. So now we should be zeroed in a little better. We'll just wait until the frame gets rid of those little trails. See those little star trails where we slewed? So the next frame, those will be gone. Then we'll start our live stack and clear the last shot. Boy, right away, there it is, bam, you know. So I like to just hit this reset. I don't know if that does any good, and then this reset. And go ahead and do a color balance on this as is, and then bring those blacks in just the way they were here at the beginning. Bring the mids down. You know, at first blush, this appears like it's not a good fit for a RASA because it's so tiny in the middle of that picture, isn't it? But on the other hand, what I really enjoy now is now that we've tuned this, look at how pinpoint those stars are compared to what we had before anyway. What this lets us do is it lets us zoom in and enjoy that ring nebula a little bit closer. M57. While that's live stacking, let's pull in from our planetarium software the narration for that object, M57. And here's what Sky Safari has to say about
M57 is a famous ring nebula, one of the most often seen objects in the sky, and the one most requested at gatherings of amateur astronomers. The ring is a sight of haunting beauty, and always brings out oohs and ahs from people at the eyepiece. M57 appears as a hoop or donut, usually whitish, but some eyes may see it as greenish. In small telescopes, the center appears empty, but in larger instruments it can be seen that the middle is occupied with a thin haze. The object is easy to find, located between Beta and Gamma Lyra, the two stars at the foot of the harp. The ring's small apparent size makes it often invisible in the finder scope, a source of confusion to beginners. A minimum of about 15 power is required to see M57. Although the ring appears fragile and small, it is worth remembering that the true size of M57 is about 45,000 astronomical units across. This is about 1,000 times the radius of our solar system.
which is pretty big. Now, you know, with a higher magnification, you know, we'd be able to make out a little more of that. But if you look really close, let me see if I can get rid of this and that and kind of treasure the big picture of that for a minute. If you look really close, you can start to see that central star forming. And it's just right there in the middle. And of course, we all know that that the way these planetary nebula form is by the discarding of the outer layers of the star that formed the center of this thing. Has nothing to do with a planet, but the original astronomers who named these started using that term, and it's just stuck. Uh, so planetary nebula, actually what it is the discarded material off the outside of that star in the middle. And in this particular case, M57 is unique because it's so colorful, isn't it? It's kind of, you know, in the night sky, it's kind of like a one of a kind object. There's really nothing else like this ring nebula. It's uh, it's cast off enough material that the object in the middle, you would truly call it a white dwarf, and that little teeny tiny white dot in the middle would be in the last stages of its development of a star before it uh, you know, is basically completely gone. And what we have here is this outer gas that was cast off, and the white star in the middle is bright enough to light up that gas, and uh, it ionizes it in such a way that it's kind of like a Christmas decoration. You know, when you look at those reds and those greens, it's just beautiful if you stop and think about it. I get a real kick out of this object because it's so unique. Uh, I mean, planetary nebula can take on a lot of different shapes, can't they? Some of them are you know, completely green. Some of them are totally round, whereas this one is so oval that the type of this particular kind of starburst, they refer to it as bipolar. And I always think that's funny because we use bipolar to refer to other things. But this bipolar nature makes it, unique to us. And if you look out at those edges, you can see little tips of reddish color out at the edge. Uh, I just think this is a very unique planetary nebula, and it's really worth catching in any night sky. Hey, we've got Kim on there from down in Australia, and Kim is pointing out that the Helix Nebula Ngc 7293 is larger and has similar colors. We'll look forward to seeing that. Jeff, it looks like it's been almost a month since you've had any clear nights. You're kind of in all that smoke, aren't you, from the wildfires, and then combined with whatever clouds you've seen. Looks like Lance, you're experiencing the same thing there in Idaho. So sorry about that. Wow, we really appreciate you guys jumping in. I'm so sorry that we got started so late tonight, but we were clouded in. Literally, the clouds moved away from the pole star at 15 minutes before the broadcast was supposed to start. So we barely made it in time. Let's bring back these side panels now in SharpCap, and this is 39 frames across 6.5 minutes. Man, there's a lot of detail already showing up, and we're just using 10-second exposures at 200 gain, and yet a lot of detail. I'm really excited about how much sharper the stars are, and let's back off now and look at this as an entire frame, and just look with me on the edges of the scope. Uh, and this is obviously looking at its full frame view, but I'm going to just really expose myself to a lot of potential problems here. I'm going to go look in the corners at 100%. And you notice we just barely get the slightest bit of star elongation in these edges. But look, I mean, this is so much better than it used to be with my RASA. Notice we're getting just the slightest little bit of tails there, but it's just barely detectable after 6 minutes. And I am so happy with this. Now, this is with, I think we ended up with 27% curvature still in our frame. And what that means is we don't quite have our back focus perfected yet. And our tilt ended up being something like 12%. So we don't quite have our tilt perfected. But the other night I noticed this got close enough that I could live with it. And you notice here in the middle, look at these tiny pinpoint stars. And this is at 100% zoom in SharpCap. This is actually the full frame of the 2600. So I'm just really excited about the progress we made over those 4 nights of torture trying to learn how to use this camera holder. It was a brand new experience for me, the Octopi-Astro Camera Holder, which it acts as the device to mate this astro-cooled, astro-specific camera with a RASA, and it gives you control over the radius, the lateral movement, all 3 axes. And so I'm really excited about the way this has turned out. Thanks for putting up with that little celebration there. Okay, we're saving up a snapshot of this at full frame, and then let's also zoom back in, and at 100% now with almost 9, there's 9 minutes of exposure. Let's do a close-up of this just for the sake of our let's see, this is M57 on 2021-08-05. And when we get back to our Astro Planner, now we'll right click this and say add a user image, and we'll load in M57, and we'll call this Finally with Pinpoint Stars. Relatively speaking anyway, compared to what we had before, Pinpoint Stars. I love that. Wow, even in the little snapshot, you can still barely make out that middle star. I'm just going to say, as a quick observation here, make an observation. I'm going to say, again, with the greens and reds, reminds us of Christmas. And then here in the attachments, right now we just add that image here in the database here, M57, and later on we can go back and pick out the full frame image and add there as well. Well, that's exciting. Thanks to you guys for being here for this first live stream back post those 4 sessions. That from our targeting software as well. That's not going to be a great view. How about M29, the cooling tower? Let's head to that
Slewing to
object.
coordinates.
These are all fairly high in the sky. You can see what happens is we do a sort based on visibility and also
Slewing
altitude.
complete.
So that means these are all near the zenith. You can see how SharpCap is showing us dutifully the star trail there, M29, and let's do a plate solve here just to make sure they're right place. Yeah, Kim, you're right. That was Vega, right? So we're now plate solving to make sure we're exactly on the cooling tower, as it's called, M29. It's otherwise known as NGC
Syncing to coordinates.
13.
Slewing complete.
Wow, looks like we were spot on to that. So let's start live stacking there. Clear out what we had last. And let's do a reset here on the side and a reset here in the middle. And while we're waiting for whoops, let me see. I heard that we can change our target on the fly now. No, let's reset that because I don't think it let us save our target on the fly. Now we're at M29. And while that's honing in and live stacking on M29, let's see what our planetarium program, Sky Safari, has to say.
M29 is an open cluster in Cygnus the Swan, high overhead for Northern Hemisphere observers on summer nights. The Webb Society of Observers calls M29 disappointing, with only a handful of stars visible. It is not a rich object, but some of the blame must be placed on interstellar absorption, which dims M29 by about 3 magnitudes. This cluster sits behind a vast wall of dust and gas that forms the backbone of the Milky Way's central core, and which also obscures M29's next-door neighbor on the Messier list, M28, in Sagittarius.
Well, you know, a lot of people aren't very cracked about these open clusters, but I always think they're kind of beautiful. You can see it doesn't have very many members, exactly like the guy on Sky Safari said. But look at that. It's beautiful. I think it's gorgeous. I know that, I mean, you could say that's just 8 bright stars there, but it is a collection of a lot of stars if you do a zoom in like that. So I think it's gorgeous. I don't know if we'll gain much by live stacking it more than what we already have. I think in 80 seconds we're seeing basically all that we're going to see of it. So let's go ahead and save it. And then I'll do this close-up screenshot as well. This is M29 as seen on 0805. It's interesting. Some of these objects I haven't imaged since the Messier Marathon, and this is one of them. I haven't come back here since we were in the middle of the Messier Marathon. So I'm gonna zoom over here to the targeting software for a second and add the user image to that. So this is M29 as seen on August 5th. And we're going to call it boy, I'm so happy with the way this RASA is now doing. So much better to have this field tuned here. And what we'll say here is, let's see, back in the general, we'll say 7 or 8 bright stars, but a nice field of Christmas lights. I think that's kind of the theme tonight is Christmas. And for here, we'll just attach that file, M29 as seen on August 5th. And there we go. Barnard 347. What can you guys tell us about Barnard 347? So we'll stop live stacking that. We'll say Barnard 347. We'll scoot this back out to the full frame. And then we'll slew to this, Barnard 347. What can you guys tell us about that?
Slewing to coordinates.
What do we know
Slewing
about
complete.
Barnard 347? That's not going to make a very good plate solve because the telescope was still settling. Barnard 347. Let's search for this in our Barnard 347. It's a dark nebula. How much fun is that? It's in the constellation Cygnus. Not huge. Still trying to solve that. I think that's because our frame that we grabbed was still moving. I wonder if we'll have to cancel this and do another plate solve because that telescope had not settled yet when we. Yep, it succeeded.
Syncing to coordinates.
Okay, so we're right on it.
Slewing complete.
This is interesting. Let's start live stacking this. We'll clear out the last. A dark nebula. Let's change our exposure. Oh my goodness, look at that. Wow, that zoomed in with 10 seconds, only 10 seconds of exposure with a RASA, and you can already start to see it. How exciting is that? Let's reset our side histogram and our big histogram down here. And then we have 3 frames stacked already. So let's do a color balance on that. And then grab these blacks and pull them in. Make that a nice black sky. And then let's pull these mids down. Look at that. We can already see that dark nebula. How is this possible in 50 seconds? Okay, I am sold on a RASA. This is enough to make a believer out of anybody. I don't know if you guys can see that on YouTube. Let's zoom into about 40%. Look at that. Can you guys see that dark spot in the middle of that nebula already popping in after 70 seconds? And let's come in just a little bit more. There we are. That's Barnard 347. I am a believer in this scope. Barnard 347. It's basically listed as a dark nebula, not a lot about it. But it does give us the chance, if you happen to be watching this, I mean, the guys that are watching with me live, you guys already know about dark nebula, but uh, if you happen to be viewing this, oh, switch screens. Sorry. Thank you so much, Kim, for rescuing us. You didn't get to see the fact that we were already watching this at 10 seconds in. Sorry. Uh, but I know that the guys that are live here with us, the Dark Nebula is old hat. You guys are very familiar with that. But if you're watching this in the in maybe the YouTube recording of this live stream and you watch this afterward and you wonder, what in the world is a dark nebula? I mean, the truth is we really don't know a lot yet about how this forms. Some people say that the best way to think about it is just think of it as a dark cloud of dust. And over time, that dust gets coated enough with ice particles and scattered the same kinds of stuff that surround comets after a while, that essentially what you have are tons and tons of dust that block out the light cloud that you can see behind this. So here's the hydrogen cloud that we should be able to see, the hydrogen nebula we would see behind this. But what we're focused on right now is this Barnard 347, which is the dark nebula. Uh, am I not sharing the correct screen? I am so sorry. Thank you, Kim. I took you to the wrong screen again. But here in the middle of this is the dark dust cloud that's covering up the hydrogen uh, nebula behind it. And dark nebulae uh, are, in a way, something that we don't totally understand, because what we're seeing here is basically what they are not, and we're formulating all these theories about what they must be by looking at them as if they are a silhouette of the light from behind them, you know? So here's this hydrogen, presumably hydrogen alpha cloud behind this dark nebula, and it is allowing us to see this this dark cloud in front of it. Um, I kind of think that we will learn more about these dark nebulae as time goes on. Uh, because right now, all we can say is they're just basically an irregular dark cloud. And we explain them the best we can. Uh, they are they are basically, if you stop and think about it, they are basically the opposite of being able to see something through a telescope. you know, because what we're looking at here is we're looking at the not being able to see it through a telescope. And that blacked out silhouette lets us formulate these theories about what dark nebulae are. Um, I think it's a really interesting concept, that we're basically studying something that we can't see because of the light that we can see behind it. Um, let's zoom out a little bit and look at the larger nebulae that are kind of gathered here. This is the bigger part of the nebulae around us. Look like we have a visitor here that made his way across. Uh, that would either be a streaking uh, meteor that streaked across, or more likely a satellite that trailed across. Um, but I don't know if you can see it or not. There are other dust clouds that are starting to form here. We only have 6 minutes, and these are 10-second subframes. But I don't know if they come through on YouTube or not, but the cool thing is we're starting to see other uh, nebulae here. Very, very dim nebulae right here as well. And I suppose to do this justice, we should. Oh, wow. This is that whole region around the star that we call Satyr, you know. Um, and this entire cloud of dust, um, the bigger part of the cloud of dust that we're looking at right now, probably would best be described as maybe NGC, maybe NGC, would it be NGC 69? No, it would be maybe IC 1318. Yeah, IC 1318. It's just this giant cloud of dust that surrounds the cloud Satyr. So let's look up IC 1318 while we're here, because that's the hydrogen alpha cloud that we're seeing. And you know, in keeping with what I always tell you guys, see IC 1318. I'm a fellow explorer rather than a guide. IC 1318, if I can spell this right. So this is sometimes called the Gamma Cygni Nebula, the Gamma Cygni Nebula, IC 1318. And it's just various patches of all this nebulosity that surround this star, Gamma Cygni, which is this star that's been named Satyr, S-A-D-R. And this cloud would just be giant glowing hydrogen clouds that are illuminated primarily by this bright star. And I don't know if we're seeing the bright star in our frame yet. Let's back off a little more. Yeah, we don't have. We'll have to zoom in on Satyr here in a sec. Let's go ahead and save this frame exactly as seen, and then let's zoom in on Barnard 347 and do a screenshot of that, just so we have a good picture of Barnard 347. 347 as seen on 2021-08-05. Now let's stop the live stacking. Oh, that might be Satyr right there, huh? Let's make sure we find exactly what is Satyr. And the way we'll do that is we'll look at the formation here. It makes it kind of a, let's look at our, let's look at Satyr and center on that. And let's zoom in on Satyr and kind of look at the stars around it. I don't think we can connect. For some reason, Sky Safari was being a little bit belligerent and was not letting us connect. Let me do one other thing here. There's this little program we use here to try to link Sky Safari to, let me just see if I can fix this real quick. I'm going to look at what my Wi-Fi address is, and double check that. And it's, oh yeah, that's the problem. We're ending in .30.177. That is a different address. So now we're going to go to Sky Safari and change this to .30.177. Now with that as the IP address, let's close that. Let's listen for this, and now let's try to connect. Yeah, now Sky Safari is connected to our scope. And this was because I did change Wi-Fi handlers a while ago. Victor, I see you've logged on and you said, I would like to see NGC 6888 that is not far from this object, mostly for frame size. Okay, we'll do that. What we're going to do real quick first is we're going to zoom in on Satyr, and now we can just go to that using
Slewing to coordinates.
Sky Safari.
Slewing complete.
And see, because now Sky Safari is linked to our telescope as well. So we basically have several things through ASCOM that are talking through to our telescope. And the great thing about ASCOM, it lets them all talk at once. So our planetarium software, which is Sky Safari, it's actually made, by the way, in case you're watching this. I know you guys that are already on here are familiar with this, but if you're watching this recording and you're wondering, Sky Safari is actually made in our case as it's an Android or an iOS app, and it's not available for Windows. So what we do is we buy the Android app, we run it in BlueStacks as an Android emulator in Windows, and then we connect it with a little utility that's written by the people at Sequence Generator Pro, and they give away this utility. It's called simply Wi-Fi Scope, and it's a free giveaway. You can Google for it. It's in the Sequence Generator Pro server. They give that away, and if you study how to do that, you use that little Wi-Fi scope to monitor the Wi-Fi that your host computer is running on. You fill in these settings in Sky Safari with that Wi-Fi address that you happen to be running on, and then it lets you connect to the scope just as if you were running it on Android out by the scope, linked to the scope with some kind of a solution like those what are those called? SynScan kind of solutions that let you link directly to the scope. So we're actually sitting 200 feet away from the scope right now. The scope's out there in the field, completely off away from this building, and I'm inside our prayer center atrium here at Emerald Hills, sitting in my office using my nice 4K monitor here, looking at all these windows, sitting inside the building, connected over a 200-foot Cat 7 cable, and yet this still works, which just amazes me that all this stuff communicates over that Cat 7 cable, and we do that via a Raven device that's made by Icron, and that Icron Raven device is their USB Raven 3104, and it lets you connect. If you're interested in this kind of thing, maybe this is very boring to you, but it lets you connect USB 3 and USB 2 objects. So we say all that to say now we're actually tuned in to Satyr in the center of our sharp cap frame, and there it is. That's the bright star Satyr. And now let's zoom out on this frame, and let's go ahead and put here in our frame Satyr, just so well, actually, let's use the name of the big nebula. It was called IC, what was it called? I'm looking here back now in Sky Safari, trying to back off enough so that we can see what it was called. IC1318, I think. You kind of got to, yeah, IC1318. So let's use that name in Sky Safari, IC1318. And let's just live stack on this, and we're We're going to clear out the old stack. So now what we're centered on is the entire cloud of dust of IC1318. And this cloud has fascinated me for some time. Look at that. That's just after 10 seconds. I tell you what, this could be a commercial for RASA. It really could. If you can take a telescope and get that kind of, result after just 10 seconds, that just floors me. Because, you look up there in the sky and try to see this, I don't think there's any way that you would pick out anything like this. But if you do this with a RASA at 40 seconds, we're already pulling in all of that nebula. Look at that. It amazes me. So we'll let that fill in a little bit, and we just want to do one other thing. Let's go back over here to our Sky Safari. Look how they say that the actual dust cloud is this big, and this is the right part of the dust cloud. Let's look at the info on this. IC1318, it is a glowing nebula, and it's along the plane of the Milky Way. And it's interesting that the Satyr is not actually part of the nebula. It's a foreground star located between us and the nebula. It's about 750 light years away, but the nebula is 2,000 to 5,000 light years away. Fascinating stuff. Boy, imagine if we would just hone in on this with like 30-second exposures. Let's change a couple of this to 30-second exposures, and let's leave that at 200. And that should give us some really nice, deep images of this. And while we do, let's ask you, Victor, if you don't mind, to tell us where you're from. Well, there's Chris Lucas logging on from Missouri. Appreciate you logging on, Chris Lucas. And, I've been wondering about you. What are you doing up this late? That's the question. Uh, But I've been wondering about you, Chris Lucas, because I know that you guys are seeing a lot of COVID. So I'm glad to see you up this late because that probably means you don't have COVID yet. For the rest of you, this happens to be my son there that's logging on from Missouri. So let's do another color balance now that we have 15 frames and tune this up a little better. Let's bring in the blacks to right there. And we are starting to see now a lot of that dust cloud that we were seeing hints about over in Sky Safari. Look down here, for instance. I'm going to get these out of your way so you can kind of appreciate this. Look down here in this lower left-hand corner. Here in this lower left-hand corner, you can start to see some of that dust cloud forming. Look at these dust cloud formings, and there's that Barnard dark nebula we were looking at a while ago. Look at these ions. Now, did you see the 30-second frame kick in? That's what happens when we go to these 30-second frames. It gives us a lot more detail on the image. So let's bring some more of our blacks back in, and then we can start to see the contrast of a lot more of our clouds. Getting these 30-second images. No COVID here, but way too much around Branson. Yikes. I can see you used a little emoji that's like somebody that's kind of out on an icicle, an ice lake doing ice fishing. But another use for that is kind of a chattering teeth, you don't want it to move there from Branson. Now, I think it's interesting to look how bright Satyr is compared to all the rest of this stuff. It's just an amazing star. And you know, the last few nights, I know you guys are going to think I'm a complete nerd here. Bugs in code, unfortunately, don't respect normal sleep hours. So that explains why you're up this late. You're actually coding in your other screen, and you're kind of watching this on the side panel of one of your other monitors. Uh, but I know you guys are going to think I'm a real nerd here, but the last few nights when I've gotten in bed, I kind of cover myself up with the blanket, and I've actually been looking at this particular set of dark clouds. And I'll tell you how I got on this subject because the part of the sky that I was using to tune this RASA um, for its image curvature and its image tilt, the back focus, problem that I had and the image tilt on the corners, the part of the sky I was using is actually very close to this star, Satyr. And that's why I got interested in this part of the sky, because I was looking for the right part of the sky to use as my test image. And uh, while I was looking for that, one of the guys on Cloudy Nights, and also, by the way, the guy Keith who runs Octopi-Astro, he said, well, you might look near the star Satyr because that's a rich field of stars. Well, I got here and I got to all this nebula, all these ionized clouds, and they were not at all friendly to being able to tune a RASA at all. They were really confusing my software that I was using for that tune-up, the CD Inspector software. So I had to get away from this cloud. Well, this cloud was so big that it took me a while to find the right patch of sky so that I had an even patch to look at. But while I was trying not to see this cloud, I saw this cloud of dust a lot, this nebula a lot, and it is huge. And it's one of the advantages of having a wide field telescope like the RASA. It enables us to pick up a huge cloud like this, and it enables us to pick it up in one large field without having to do a mosaic. So again, I know I'm giving away, like, it sounds like Celestron is paying me, but they're not. Also, look from this view in those corners at those pinpoint stars now that we've tuned this. And those used to look like seashells in one corner, and another corner they'd look like, uh, giant uh, shellfish, manta rays. And then you go to a third corner, and it'd look like a comet with a tail. They were so ugly. And now at this wide frame, they're still very beautiful, even with these 30-second exposures. And I'm not guiding tonight. That's my next step. I have the guide scope on the RASA, and I have an ASI 178 monochrome camera ready to start guiding. I just haven't started doing it quite yet, but hopefully on these longer exposures, we'll see. Well, we're at about 8 minutes, and I think 8 minutes is long enough. Uh, we're able to pull these darks in now, and and darken that sky, and then we're bringing in the contrast. We don't want to get it too dark because that actually begins to hide part of the reds. So it's basically a balancing act. This is where it's part, art, uh, as much as it is skill. Let's do another color balance while we're at it and see if we can pull out a little more of those reds. Yeah, I think that helped us. But see how that crest. I tell you what, I think I'm gonna hit my shift key and bring the greens down just a little bit. Oh, that was too much. Bring the greens down, not quite that much. And I've got my shift key. Rats, that's not enough. That's fairly, okay, that might do it. Now look at the blacks, and now when I bring these mids up, maybe it won't show us as many greens. And we're kind of now highlighting all of that red hydrogen dust cloud without putting a hydrogen filter on our scope. Um, so let's go ahead and save that as seen. That's exactly the effect that we were looking for. We wanted to be able to see IC1318 illuminated. And in this case, we don't have to take a screenshot of something smaller because IC1318 is filling up this entire frame. That's how big it is. Huge. This is a huge object, and if you didn't believe that, let's go back to our Sky Safari. It's big, and you can see that this rectangle in Sky Safari, I've got this set up so it shows us our field of view for our RASA, and look how this object is a perfect use case for buying a RASA, you know, because and mating it with the 2600 with this wide field of view, it's a great use case. And if we played around, we could include this thing up here. I guess that's just more of this giant, I guess, is that more of this same dust cloud? I guess it is. Yeah, it's just a different view of more of this IC 1318. This is a great use case for a RASA, and if we tuned it up a little bit, we could see even more of this dust cloud. Now, so we've saved our image of this. Let's stop the live stack. So we're going to go back to SharpCap and stop live stacking. What a beautiful picture that was. And now we're going to go to this star that Victor wanted to see. NGC, who knows what that is? It might not be a star. That might be a nebula. Huh? So I'll tell you what, it's going to be easier to find that now that we've got our Sky Safari mated with the telescope. Let's just search for it in Sky Safari. NGC 6888. Oh, it's the Crescent Nebula. Okay, well that should be beautiful. So what we'll do is we'll center that in our view. Yeah, you're right, it's real close. And then we'll go to that. And I'm looking
Slewing
here
to coordinates.
on our little
Slewing
iPad
complete.
here, watching the scope outside in the dark about 200 feet away. On another night, I'll get that set up so you guys can watch the scope too. I just couldn't work out all of the bugs. You know why I bet it wouldn't mate is because of that change I did of which Wi-Fi was on here at our office. I changed Wi-Fi at the last minute. I bet you anything. That's why we couldn't mate our iPad with our um, laptop. I'm going to go over here to our Astro Planner. I'm just going to search. I think the easiest way is to use see NGC. You know what? There's another way to do this. That is plus sign NGC. What is it called? 6888. And if I've got it in my targeting software, it'll take us right to it. And I do. And let's go over to SharpCap now and change that object name to NGC 6888. We're back out of auto. Let's bring back our camera controls and do a plate solve for that. Takes it a second sometimes. This is a wider field for it to try to plate solve. What it does first is it downsamples the field so that it can make it a little easier to compare it to its database. Otherwise, it's comparing literally hundreds and hundreds of stars to its database. So it downsizes it.
Syncing
and we
to
were only
coordinates.
off
Slewing complete.
1/100th of a degree. So that shows, that's a good commercial for the Skywatcher, isn't it? So we'll do a quick reset there, and then we'll let that go away, and then we'll start the live stack and bring it back up and we'll clear it first. And why don't we just keep it here for a minute? Now we've got that set on 30 seconds, which probably is not a bad idea for this object. You can see it pulled it right out. It's kind of overexposing though, isn't it? Some of that we'll fix though with when we stretch our live stack correctly. Boy, our camera controls have gotten all mixed up here. There we go. Let's do a reset of our main histogram. And we've got 2 frames in, so we should be able to reset and do a color balance on those peaks. And then bring these darks in. So we darken that sky some. And then bring the mids back in. And there we start to see the Crescent Nebula. Now, we've got 3 frames in. Let's do another. While that's live stacking, let's go over to our planetarium software and listen to the audio tour of this.
NGC 6888 is a faint loop-shaped nebula near the star Gamma Cygnus, the middle star of the Northern Cross. Little is seen in a small telescope, but a 200-millimeter reflector begins to bring out a faint narrow band, like a piece of string, which forms a portion of a circle. A much larger telescope is needed to see more. This nebula is in the same field as the variable RS Cygni. This is a very red star and dips in brightness over about 400 days. It never gets too faint to be followed with small telescopes, and is therefore suitable for those wishing to tackle variable stars.
So this object is 20 arc minutes by 10 arc minutes. And it looks like it's 4,700 light years away. And they say that this object was formed by a fast stellar wind from this star, HD 192163. It's a Wolf-Rayet star. That's the classification star it is, WR136. It's shedding its outer envelope, so it sort of would remind you of what we looked at when we looked at what was that, M57, whatever, that planetary nebula that we looked at that was called the Ring Nebula. So it's shedding its outer envelope. It's just that this Crescent Nebula, it hasn't shed it in such a way that it's formed a ring. It's just a crescent. And it ejects so much material, apparently, that it's equivalent to the sun's mass every 10,000 years. And this stellar wind collides with and it energizes the slower moving wind of the ejected star, and from when it was a red giant around 400,000 years ago. And this collision of that ionized stellar wind with the shedding of the outer envelope, the collision of that stuff is this shell, which is about 25 light years across. So it's basically, you could think of it as 2 shock waves that are colliding. One's moving outward and the other one is kind of moving inward, and it's heating this wind to temperatures that are on a level of X-rays, and it's actually picked up by X-ray telescopes that can read those. So this central star, which is again WR136, probably will undergo a supernova explosion sometime in the next million or so years. So I don't know, that WR136 is probably from a catalog of stars, all in the catalog of WR. So that's something I'm going to have to do some research on because I've not ever looked up WR stars before. Wolf-Rayet stars. So that's interesting to me. Okay, let's just make sure we're pulling out everything we can pull out here. And let's just cheat as much as we can from this. We don't want to let that start to color the entire plane. Now let's zoom in a little bit so we can see that a little bit closer. I think we're going to be able to go in. This is such a small object. I think we're going to be able to go in at 100%. And let's get rid of these panels for a minute. And let's just admire this thing for a minute. Wow. The Wolf-Rayet star obviously must be this one. And it ejected this material, but it's colliding with stuff that it ejected while it was a red giant. I can see why, Victor, you wanted to see this. And it looked like you wanted to see this to get an idea of the frame size, too. So, Victor, if you can, if you're still with us, if you can in a moment, kind of tell us if this is what you kind of wanted to see. I think you were wanting to see how does this stack up in a RASA. And what I can tell you is paired with this 2600, which is a very, very high megapixel camera, it does give us quite a bit of zooming power. But what I was finding over the last month is when you use that zooming power with all those pixels on this wide frame image camera, it invites incredibly, it lets you see all the problems with your image train. Now, here's something that's interesting that I'll point out to you on purpose. Do you see how this little object here is red and this little object here is blue? Those are pixels that we'll have to sort out in our calibration frames that we haven't shot yet. Just to give you an idea of what you're looking at here, this is no darks and no bias, no, there are absolutely no calibration frames here at all. And we have some available from a prior imaging train, but I don't think they'll do us much good. Uh, I can say, let's subtract the dark frames, and we have some here at 30 seconds. And I can say, I could go shop for some flats because I've shot flats before, but let's just see if that dark does settle that pixel problem that we had, and it didn't. So see, it's because I'm using a completely different imaging train now with this Octopi-Astro camera, and these darks and flats are no good to me since I've changed the imaging train so much. So that'll be my next challenge is I have to shoot those darks and flats again to be able to calibrate these images a little better. But wow, even though they're not calibrated well, I'm really happy with the way that it's coming out with absolutely no calibration at all, just uh, with the bare bones of this imaging train. It's really, I think, performing well for us tonight to be able to catch and see what we're seeing here. All right, let's save at 9 minutes. Let's save exactly as seen. And let's see. Let's also, in this case, do a close-up of this with our screenshot capability. And we'll just call this, see, it was called, what was it called? NGC 6888. And I imaged this on April 2nd. Isn't that interesting? I'd seen the Crescent Nebula on April 2nd, 0805. And now let's go back while we're at it and look at what Victor might have said. It's what I was thinking the view would be over FSQ 106 and 8300 chip that I use, but I'm surprised by the zoom. That's my field. Okay, so Victor, um, I'm not familiar enough because I'm still a rank amateur. Tell us what an FSQ 106 is. Is FSQ 106? Now, give us, if you don't mind, tell us what scope and camera you're using. It sounds like you're using a camera with an 8300 chip. Maybe that camera is the FSQ 106. So you'll have to tell us that so we can become familiar with your imaging train. We're going to stop the live stack now. Oh, a talk. You've got a talk. 106. My goodness, you've got one of the nicest telescopes made, for Pete's sake. And then what camera? You can tell I'm not very sophisticated at picking out what an FSQ 106 is. Please forgive me. Tell me what that camera is. But that's just because, again, I'm 7 months on, on this. Maybe 8 months now, I guess. You've got a TOC 106, and you pair it with which camera? I guess that's our question. While you're doing that, I'll go back over to our a QSI 683. Okay, that helps me. Now I kind of know a little bit more what we're talking. Wow, I'd love to see some of your images sometime. I'll have to look you up, Victory. If you don't mind, tell us what your handle is. Your avatar name is on Cloudy Nights. Okay, we'll try the Helix Nebula next. Let me record this observation real quick in our. This is amazing, and we're gonna go grab NGC 6888, and then back here at the observation. That's actually a great image of it there, the way the monochrome camera they gave us. But I'm going to add my user image here just because I captured it myself, NGC 6888. It won't be as colorful, will it? I did not make that color pop as much as that monochrome did. Yeah, that's more subdued, but it is color nonetheless. And now the Helix Nebula. So what I'm going to do is just go over to see Sky Safari and just search for Helix Nebula NGC 7293. Wow, that's beautiful. Now let's just study our thing. It transits at 3 a.m. So right now it should be 26 degrees. Okay, so the answer is, Kim, it depends on 153. It depends on where 153 is in the sky. Let's try it. Let's center it first. That is fairly low. It depends on where that is in my
slewing to coordinates.
In my sky. Because there are, where I've set up the scope tonight, there are two trees that are kind of bothersome. And it's possible that it would be behind those two trees.
Pier West.
Everything else except for those two trees, we should be okay. kind of watching it. I'm watching it here on the iPad. Oh, I think we're going to be okay. Okay. Oh yeah, it's going through quite a gyration. It's going way down in the southern sky. There you see the
Slewing
field of view.
complete.
There's the field of view of the telescope. Since it's now synchronized with Sky Safari, you saw the field of view come over the object. Now let's go over to NGC 7293. Let me just go over here for a second and see if I've by chance NGC 7293. It's in the plan, so I wanted to image it anyway. So there we are. Now let's go to SharpCap and let's make that our name of the object. NGC 7293 it was, right? NGC 7293, I believe it was. And let's plate solve that. We're at 30 seconds. Tell you what, while we're plate solving, let's go back to 10 seconds. And let me just let it capture frame there. NGC 7293, Helix Nebula. How about that? I don't think I've personally imaged this before. I could check over here, couldn't
Syncing
I?
to coordinates. Slewing to
No,
slewing
I've never
complete.
observed this myself, so I'm glad you. Now we crossed a big part of the sky. We were 3/10 of a degree off by the time we traveled that entire sky. And I guess that's just, I'm looking to see, make sure I didn't have a cable problem. No, it's just because we did a meridian flip. And in the process of doing a meridian flip, we did lose 3/10 of a degree of our synchronization. So I'm going to change this back to 30 seconds, I think, and start live stacking. Clear out what was there before. And then while we're waiting for that, let's see if there's any info here. Oh yeah, there's an audio tour of this.
NGC 7293 is the Helix Nebula in Aquarius. This planetary is very large, and unlike most planetary nebula, the Helix can be easily seen in 80 by 20 binoculars or even smaller instruments. It looks like a ghostly disk sitting amid a rather barren field without many stars. In 150 millimeter, it's a large, pale, and colorless disk. In moments of good seeing and with at least a 200 millimeter telescope, it shows an annular disk, like the ring nebula M57 in the HARP. Yet the surface brightness is low and is more difficult to see that this is a ring body. The Helix is also hard to find, since there are few stars to navigate with in this area. It is roughly 10 degrees northwest of the first magnitude star, Fomalhaut.
We really cheat with these mounts, don't we, guys? I mean, sometimes I feel guilty. I mean, I'm looking at my iPad here so that I stay synchronized with my scope. I mean, I want to be one with the scope, like some kind of ninja warrior. I want to be one with my scope. So I'm looking at where it's pointing, and I can see exactly where it's pointing. But boy, we're cheating with these go-to mounts. Here I am sitting inside in the air conditioning away from the bugs. And by the way, this iPad view, my little Wise 3 surveillance camera out there by the scope, there are moths and bugs and mosquitoes all over this field of view, just even from the infrared view of the Wise 3 data, surveillance camera. Uh, the scope is not illuminated. If you look at the telescope, if you step outside the door and look at it, it's just a black field out there. It's sitting out in a black lawn. There's no light, but this Wise 3 has an infrared light that illuminates it, and there are lots of moths that are attracted to that infrared light. We are so spoiled by being able to do these remote observing, aren't we? Here I am sitting inside this building, and this guy is talking about how hard this image is to find, and we slewed there at the touch of a button because of these mounts that we use on these tripods. With this software, it's just not fair to Galileo, is it? Uh, but such as we have, it lets us do a lot more objects in a very short, a lot shorter amount of time than what we used to. So there you go. There's the full frame, Kim, of the Helix Nebula. It says I imaged it with an 80 millimeter scope a few days ago, and it would be interesting to see it imaged with your RASA. So there it is at full frame, and I don't know how much to cheat it yet. We're getting quite a good number of frames to be able to do a good color match. I like to pull that green down just a little bit more so we can cheat on these. But now that's not really fair, is it? Because this object has green in it, so let's don't do that. Let's leave the green natural and let's pull this back so we aren't cheating the sky too much. See, I'm running a Celestron light pollution filter, and I'm in Bortle 5, Bortle 6. Yeah, I think you're right. I think increasing exposure and gain would help. But we're just at 3 minutes also. I don't know how long you imaged it at 80 millimeters. I don't know how long you imaged it to be able to see it. We're at 3 minutes and a half right now. Honestly, I don't ever have to do much more than 30 seconds and then stack frames. But sometimes I stack, on an object that's faint, I do sometimes stack 7 minutes. Victor, I'm looking to change from long exposure to short and more electronic eyepiece without all the time and work. This looks fast paced with something to do over boring sitting as filter change. Man, you are right. Kim does 3 minute subs. See, with a RASA and with this 2600, I never have to do 3 minute subs. It's just, you never have to do it. We will be able to pull in a lot of this object by the time we're done if we stick to 30-second subs at gain of 200 and we just tune the histogram well. We'll be able to see a lot more of this object as time goes on. It does sometimes take 7 or 8 minutes on certain objects. Victor says, I have tons of data and dislike processing. Victor, you are reading my mind. You and I are cut from the same mold. I do not like that. I like to be able to see it almost real time. Kim says, hence my interest in the RASA. Got it. Let's do a zoom in here, maybe 50% or even more. Let's go ahead and let's do 100%. Now at this point, you're starting to see a lot of the texture here, and you're seeing the greens and the reds and the oranges. And just to put things in perspective, this is at 5 minutes. So in other words, you're doing, and I'm not meaning to compare scopes, but you're doing 3 minute subs, and then I wonder how many 3 minute subs do you do, Kim, to get a really good image of this? Maybe 3 minute sub is all you need. You're at 5, at a focal ratio of 5.5, yeah, which is a fast scope. I mean, I think of, when I think of a telescope that's focal ratio 5.5, that's fast. Um, but this is just over the top fast, isn't it? Let's go down and see how many live frames we have now. We have 6 minutes of data. So this would be equivalent to 2 of your frames. Oh, so you do 5 to 10 frames. So between 15 minutes to 30 minutes. And I want you to know, with deep, deep respect to the other kinds of scopes, I have never in my life had to do 15 minutes on anything. It's just a different uh, world to have this F2. But I want to tell you, the problem with F2 is the last 4 nights, 6 hours at a night that I've spent tuning this image train with trying to get rid of the field curvature and getting rid of the image tilt. And I'm still not perfect. Like I say, 27% focal curvature, back focus is still not quite right, and 12% tilt. Uh, that's the curse of the RASA. It's a lot more demanding for those, uh, imaging train issues. And I think it should never be used by a person who's like I am, an amateur that's just a rank beginner. This should be a scope that you do once you learn, I think, once you learn astronomy, then you should be able to get a scope like this. Nobody should have ever put this in my hands because I don't know enough yet after even 8 months to be able to use it. But I'm making progress, as you can see. Uh, yeah, Kim, exactly. The struggle is real at f2, getting rid of that image tilt, getting rid of the field curvature, and then you can also see because I did the new image train. Now we've got this blue pixel here, this red pixel here. These pixels that are not calibrated out yet that I'll get rid of in my darks and my bias frames, my flats. But I'll do those and I'll get rid of them next time. So Kim, this image, is this beginning to be what you were seeing when you were imaging it? It's it's evidently one of the largest planetary nebulae known. It's 16 arc minutes, but uh, your approach is to shoot at a high gain and then to accept the noise and then wash out the noise by stacking subs. Uh, I see. Yeah. So let's do this. Let's do this at 10 seconds and let's put this at a gain of, I don't know, 300, and let's just see what that adds to our live stack. I'm interested in seeing what this would add. Um, this Sky Safari write-up, it's a huge write-up on this, very popular nebula, of course. Um, this 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 write-up says that because it's uh, such a large area, that this high uh, magnitude scatters out over a pretty large area that gives it a low surface brightness. And it says it's not at all easy for a visual observer at all. And evidently the Herschels, for example, never even they never even observed it at all. And you can't detect this very well apparently in in the kinds of scopes that they had. But if you use these O3 filters and UHC filters and then do a lot of processing, you can make it super bright. Um, it is just 650 light years away, which I find interesting. That's pretty close as planetary nebulae go, isn't it? 650 light years is not that far. I mean, what? The Milky Way is 100 light years across, right? So this is actually pretty close. Uh, but wow, it's 2.5 light years wide. That's incredible. It's about 10,600 years old, and it's more spherical than the one we were looking at a while ago. A little bit oval though, isn't? There's a little bit oval structure. Let's uh, let's go back here and look at our color balance, and then let's dial down these blacks a little bit, and then dial up these mids a little bit. And there we're starting to get it a little bit brighter. I honestly think if we dial that dark, maybe around, well, of course, we're losing the contrast now. We don't want to lose the contrast. Oh, good. You emailed your image. John is asking, hi, John. Good to see you. Glad to have you aboard. This is the Celestron light pollution filter that they kind of pitch as being a perfect mate for the RASA. And I am at right between Bortle 5 and Bortle 6. Keep in mind, though, I have not, this is just back to live observing again after this month of trying to tune this thing. So I haven't shot darks and flats yet, so that's why we're getting these, uh, you know, non-calibrated pixels here, unfortunately. But this is the light pollution filter, and I just run it all the time because I'm in Bortle 6. I'm just right on the border of a Bortle 6 Louisville sky, and I just have to keep that light pollution filter in all the time, or the entire sky would be blown apart. Well, this is 12 minutes, so we're going to assume this is all we're going to get, I bet. So let's save an image of this. And I mean, we could do more, but this is probably about it. NGC 7293. Well, I'm glad you asked about this. It was already on our targeting list anyway, Kim, and I think this NGC 7293, NGC 7293, my first time to look at this on, as seen on August 5th, and now we'll go back over to here, and in our observation of this, we'll say large planetary with low surface brightness scattered across the full width. And then here we'll attach that file, NGC 7293. Not bad. Not great, but not bad. And then here we'll also, now their nice mono image is very bright. Ours is going to be a lot less, but nevertheless it's ours. So 7293, here we go. We'll call this color. Yeah, cool. Now I don't know if I open up my email. Let me open up my email and grab this and open up that image. I'm going to open that in a separate window. There we go. And then I'm going to go to our broadcast software, and that's because I use this silly broadcast software, I have to add an image of this. And here I'm going to image. This is create a new, and then that's the wrong way to go about that. I should be able to add a window capture. That's what I want to do, is a window capture of $72.93. Now I got to find that. There we go. And then how do I guess I can do it like that. Trying to get this ready for you guys to see it. There we are now. Hopefully that switched. Are you seeing that? Sometimes this broadcast software is more trouble than it's worth, huh? Yeah, you should be seeing that. Let me go back over here and say, Victor says that's part of my interest in color camera for one shot over monochrome and filter. Monochrome filters. I would be happy with your image and move on. That's the way I am as well, Victor. We're cut from the same cloth. So Kim, are you seeing? I think you're seeing your image now. Uh, Tell us how many minutes this was, Kim, when you get a chance. Was this? You said it was 15 minutes or 30 minutes. Tell us what that was, because this is a beautifully bright image. And remind us, if you don't mind, Kim, what scope did you use to gather this? Uh, you were on the 533 with an L Pro filter, 3-minute subs, no post processing. Thanks, Victor. So, what's your telescope again? Remind me, Kim. I forget what you're on. Are you on a? You're on some kind of a. I think you're on. Are you on a? I can't remember what scope you use, Kim. Is it a Newtonian 8-inch? Maybe you're on a something like a. Oh, uh, Williams Optics 80 millimeter 5.5. That's a wonderful scope. Williams Optics, that's incredibly good. It's no wonder you ended up with an image this beautiful. I love this. Okay, well, let's go back to SharpCap and stop the live stack. Man, that is a cool image the way it refracts. And then let's do one more. I know you got no, it's 2 minutes still. I got to let you guys go. We're within 2 minutes of our bewitching hour of 2 hours. I guess I'll go back here to the um, targeting software and just say, um, you know, when we go through a typical night, we're just basically heading down this road of this targeting software, and we're we're just basically covering one at a time until we observe everything. And then what we can do is we can say, uh, you know, highlight the ones, for example, that are observed, you know, and we can then filter for those and see the things we've observed and things we haven't. And then next time we can start with the things that we haven't observed and just keep on working through new objects. And tonight, I didn't do that. I went back and kind of did some of the Messier objects again, just because it felt good to have the scope live again. After a month of basically being a technician. That's what I was for a month, is just learning how to operate a camera holder for a month. And I guess, we all have to go through that kind of thing, don't we? Because otherwise we'll never get our scopes calibrated. But I'll look forward next live stream, when next clear night in a week or so, or whenever we have another clear night. I'll start with unobserved objects again, and we'll scout out some of those lesser known objects. Thank you guys for being a part of this. My goodness, Kim, it doesn't look to me like you're still learning. It looks to me like, 60 minutes total. Wow. That, no wonder it looked that bright and that beautiful. It was gorgeous. So, and I also envy you, because a Williams Optics refractor is like, I hold it right up there with the talk. Though that's a beautiful refractor. So anyway, thanks to you guys for being here for the live stream, and for you guys who are watching it recorded. Thanks a lot. If you do watch this and you want to click the subscribe button if you like content like this, if you are still watching after all this time, you stayed for the whole 2 hours, and you want to hit that bell so you'll be notified when we do a live stream. And maybe if you want to click thumbs up, that's up to you. It is a way that it helps Emerald Hill Skies. And since we don't, get any kind of, we're not looking for monetary gain. We're basically just looking for a way to get the word out. This does help us, I guess, as a way that you can give something back to the channel without having to give any money and without me having to ask for it. So we're not out for money at all. We're trying to figure out how we can get the word out. If you'd like to do that, thank you guys for being a part of this, and for those of you who watch this recorded, bless you for hanging in there. For Emerald Hills Sky's sake, we appreciate you being part of this live stream. We look forward to seeing you next time. So we'll go ahead and close out for now. Wish you a great night wherever you are in the world. Thank you, Victor. Thank you, Kim. Thank you, Lance, for being here with us, and John. And I don't know if you stuck around this whole time. Jeff, if you did, I know Chris, you're probably into coding by now, but all of you all that watch this, we appreciate it so much. We'll look forward to seeing you